Aloha, Rich Alverson here. This is ICS211, and in this video, I'd like to finish up Chapter 2. So, if you see where we are in this syllabus, we see that I'm going to try to finish up. Look, I'm already half a day behind. I'm going to try to finish these up today. And one thing I'd like to mention is that the first 5 or so chapters that we're doing, and even on into a couple of these, those are the repeat chapters from the previous semester. And so you should know all that stuff. I'm doing it because I want you to get to familiarize. I want you to become familiar with the way the textbook works, how the assessments work. And also, if you're coming from a different language, like if the first programming class you took was Python, then, you'll notice I skip a lot of the stuff in loops and conditions and stuff because that's all the same. But what's different is the syntax of the language and how the variable declarations work. Those are the differences. So anyway, let's go to Chapter 2 and finish up. The other thing I want to mention is that because I want to reinforce, because everything is auto-graded, that's why I can do this. The due dates are recommended, but everything has to be done by the end of the semester, when the last day of class or the day after the last day of class, when I download all the grades one last time and put them in Laulima and compute your final grade. And so as long as you get everything done by then, you don't have to ask me for more time to do, assignments through the session, because the answer will always be, yeah, just make sure you get everything in by June 30th or July 1st. And that the specific time will be announced more towards that time because it has to do with my schedule when I got to get things done. And up to the registrar. All right, so we are in we've done 2.7. We did last video. Let's do 2.8. And now we're going over all of the different number representations in Java, which are different for different languages for the most part. And we can, it's still a double type, but we can specify the value this way, which is 6.023 times 10 to the minus 23rd. 10 to the 23rd is Avogadro's number. Atoms per mole. It's how many atoms are in a mole. All right. So you can just write it that way. And it's going to be treated like, see, this is for 10 to the minus. 1 times 10 to the minus 3, which is, 1/1000th. And they always, it's a good idea to put the leading 0 in there if it's a 0. All right, so make sure you type this as a floating point literal with a single digit before and 4 digits after the decimal point. They just tell you what the answer is. 0.123. So it's 10 to the minus 4. So the decimal point is right here, and that would mean you go minus, 1, 2, 3, 4. So that's what the minus 4 is. Is that the correct answer? Yes, it is. All right. So you go through. Oh, here's a challenge. Let's do this very quick. Compute the acceleration of gravity for a given distance from the Earth's center. Distance center. That's what it is assigned the result to that. The expression for the acceleration of gravity is that, where g is the gravitational constant, m is the mass of the Earth, and d is the distance in meters from the Earth's center, stored there. Note, assume the distance is at least the radius of the Earth. Well, that makes sense. All right, so It looks like we have to go first of all. Acceleration of gravity. This is all confusing to me, but I'm just going to do it mechanically here. Okay, so it looks like we're calculating this acceleration of gravity. Let me copy this somehow. And I'm going to, my code starts here. Control V, paste. Okay, the acceleration of gravity is this. Copy this. And I put equal, paste. And G is G. Oh, look, this is G, so I can just leave that the way it is. I multiply, that's a multiply, all right. And M is this, divided by D squared. D is the distance. It's in this, there we go. So it's this. Oh, I just read that in. So it's distance. Okay, it's this, I guess. It's distance times distance, right? That's distance squared. Distance times distance. All right, so really, yeah. Okay, so that's what that is, and we're supposed to write it out. Is this all there is? By the way, you know, I wonder if we actually need any of these parentheses. Yeah, you do, because if you don't have the parentheses, this does not end up being in the denominator of this division. So anyway, let's run this and see what happens. Oh, what did I do wrong? All right, so I did that one. Yeah, so my intention is to go ahead and do all of the, you know, all of the challenge activities and labs for those sections that are from those previous chapters, which you should know. And so I'm not going to, you know, so just go through them or go through them on your own or go through them watching the video. And it's not until we get into the new stuff where I'm not going to do all the challenge activities. I'm going to leave challenge activities for you to do, and I'll leave more and more. I'll still do one from each section just to get you started on the thinking. But then, you know, then those will be more or less the assessments. The other thing I wanted to mention about points is that, you know, I'm of the philosophy that there are easy points and there are hard points. And so that's why we can have, you know, 60% be a fail because you only got 60% of the points, and because there's a whole bunch of easy points that everybody should get. So you got to make sure you get all those easy points. And then after that, it's if you can get all the points, and there's going to be some points at the very end that are very difficult to get. And so even though the 10 points, there's two problems that are 10 points, and one is real easy and one is real hard. Well, you're certainly expected to get the easy one. So, so that's how I can justify the huge variance in the number of points that are given for the same for these assessments. In other words, because some assessments I give you the answer to, and other assessments I don't give you the answer to. So anyway, so let's do the next one, which is constant variables. Okay, so you can define constants, and that's the key word for defining a constant is different in different languages. And in this language, it's the word final. It's not going to change. And there's a convention that when we define constants, we use variable names. We use identifiers that are all capital letters with underscores as spaces. And so they look like this. And the whole idea is that you can't a final variable or a constant can only appear on the right side of an assignment statement. You know, after it's defined, it cannot be on the left side of an assignment statement, which means You can't change its value. That's all. So blah blah. Okay, so you don't. Oh yeah, you do put that there. You put the type, but you put the word file in front of the type. Okay. So go through that. Oh, here's a challenge. The cost to ship a package is a flat fee of 75 cents plus 25 cents per pound. Declare a concept called cents per pound and initialize it to 25. Okay. Final. We're doing everything in cents, not dollars. Okay, so it's an int. Flat. Oh, oh, it tells me what I'm supposed to name it. Okay, anyway, so cents, that's right. Okay, so first I'm supposed to declare this. Cents per pound as equal to 25. Semicolon. Final int. Get the shipping weight from the user, or ship this. It's this. Get the shipping weight from the user, which is that equals SCNR dot next int. And then I'm also supposed to use this and assign this thing. Okay, so it is shipping cost cents. This thing. So I'm assigning this a value. This flat fee of 75 cents. Where's the flat fee cents? Flat fee. No, we have chickens around. Flat fee cents plus I would say ship weight pounds times cents per pound, semicolon. So that is defined. This is defined. This is defined. This is defined. And the reason I don't need parentheses is because, you know, really I want this calculation to happen first, and then we add this on the end. Okay. I don't want to add this to this and then do the multiply. Well, the reason I don't need the parentheses is because this multiplication has precedence over plus sign. Precedence. Although in some disciplines they call it precedence. Anyway, so let's run this and see if it works. All righty. All right, what's next? I only want to do this. Okay, so using math methods. Okay, looks like I do the next two, and then I do the. This is easy, just 2-point lab there, just to. So let's do math methods. All right, so learn 2, 3. Okay, so we got 3 challenges in here. Math methods are just like in any other language. There's a math class, and you do math dot and then the name of the method, and it's a method. So some you might put parentheses, even though there's no arguments, and you just use them, and they return a value. So you can use them on the right side of an assignment statement. big deal. So, you know, if there's arguments, these are the same in every language, pretty much. So there's square root, x to the power, absolute value, blah, blah. So go through this, make sure you understand everything. What is y? 2 to the 8th power is, let's see, this. All right. Here we're using the math power function. All right, so let's get, ooh, look at that. It's nice square roots. Okay. Okay, method call and an argument. Click through that, make sure that's clear. Okay, using math methods. Type the program's output. Blah, blah, blah. X equals the square root of 4, which is 2. And we're going to print this now, which is 2.0. Enter. Methinks. Yes. All right, this one is 1.3. Enter. It's not a trick question. This one is 3 to the 2nd power is 3 times 3 is 9. And it's a floating point, he thinks. These are just too easy. What's 13 plus 9? It's 4. It's minus 4, but we're doing the absolute value, so it's positive 4. 4.0, enter. Absolute value of that. Now, the last one is the square root of 9 is 3. You got to do what's inside first. The square root of 9 is 3, and that's, so then it's 5 to the 3rd power, which is 5 times 5 times 5, which is 25 times 5, which is 125.0. Methinks. Oh, gosh. Forgot to put the return. Forgot to do this. All right. What's next? Writing math calculations. All right, write this. So it looks like y over square root of x. We've got some y's, read in some a, just write z. We got the y. Okay, so I just got to write z. Start. Z equals y divided by math SQRT parentheses x semicolon. That's right. I'm pretty sure that's right. Next level. Oh, now I gotta write this. Okay, well, I'd say this is z equals math SQRT of something. What is it of? It's of x minus y to the 3rd power. Now I can use the math function, math.pow, or I could use just y times y times y. I like the y times y times y. Y times y times y. It's probably faster. I'm positive it's faster. All right, so is this Is this correct? I think so. I fooled it. Anyway, what's next? What am I gonna write? This? Goodness, they're just trying to Z equals, let's see, the whole thing is math.sqrt, and inside there is something math.abs, parentheses, x times y, close the absolute value. Well, I got to multiply that by 3. Well, this time I'm going to, so it's already absolute value. So I could, all right, well, this is what they're looking for. They want math dot POW of this to the third power. And then I have to close the square root parentheses. Yeah, see, so that closes the square root. Okay, I think this is the answer that they're looking for. And so I'm just going to say, okay, so that's the answer they're looking for. But I'm going to try something different, okay? I'm going to be fancy. So I'm such a smart math guy. I'm going to say Z equals math square root. Granted, I'm so smart to reduce that. But then I'm going to say x times y absolute value. That means it's going to be positive. Whatever x and y are, it's going to be a positive number, whatever x times y is. And then we take that to the third power. Okay. So I was going to go, I still might have to do absolute value. Let's see. Yeah, I still got to do absolute value because it's to the third power. Okay, all right. X times y times y times y times y times y. Is that, will that work now? That should work. Let's see if I get the right answer. Oh, I got the right answer. So anyway, but you see, that's what they're looking for right there. All right, so that's the end of that. Oh, there's one more. Distance. Now they really try to get you, don't they? Well, we got all these here. We got x1, x2, y1, y2. They were read in. We initialize. Why do we have that? Oh, distance between this point is the result of that. Why are we doing an x distance and y distance? I don't know. I'm gonna see if this works. We want points distance. We want this. See? Paste. And we want that to equal, isn't it just we got x1, y, x2, y1, y2? I'm just going to write this distance formula. Math square root of I'll just use math power of x2 minus x1 parentheses comma 2. So that's x2 minus x1 squared. And I want to add to that math power of y2 minus y1 comma to the second power. And I'm taking the square root of the whole thing. I wonder why, I wonder what these are for. Well, I'm going to see if this works. All right. Well, all right. What's next? 210. Okay. Oh, I got to do integer division and modulo. And then I get to do the train. Okay. All right. Integer division. Okay. So, in this language, a slash is either integer division or floating point division based on the operands. It's always a slash, though. It's not like you got two slashes for an integer. Anyway, so it does not, integer division does not generate any fraction. When the operands of this are integers, the operator performs integer division, which does not generate a fraction. Okay, fine. So that's integer division. However, what happens? Oh, the slash operator performs floating point division if at least one operand is floating point type. So if at least one operand is floating point type, it turns into floating point division. All right, that's how division is. Divide by 0. For integer division, the second operand of a divide or a modulo, which is the same, this is the same in every language. It can never be 0 because you can't divide by 0. And it's the processor will cause an interrupt there. And you see that, and so you got to do something to make sure that doesn't happen. All right, modulo, that's just the remainder. You all know about modulos, aren't one. Oh, it's because I'm covering this because the definition of the slash is different in different languages. Enter the output of this one. Okay, so let's get started. Okay, so I'm going to print x space y. Yeah, because this is a character. So x space y. And so what is x? X is 2. And what is y? Y is 2 plus 9 is 11, plus times 2 is 22, it looks like. 22, and there's no return. That's right. Okay, what's next? X space y. X is 2. Y is 2 times 3. 2 plus 3 is 5. Times 3 is 15. Plus 5 is 20. No new line. X is 17. Y is, everything's an integer. So 17 divided by 2 is like 16 divided by 2, which is 8. 8, oops, 8. Let's take the 8. No new line. All right, what's next? 5. First I do the 5, and then I do y is 5 mod 2. 5 divided by 2 is 2 with the remainder of 1. Okay. So y must be 1. If there's a expression like this, the result is never going to be, it's going to be smaller than this number always. So that leaves only 1, 0 or 1. Anyway, so this is the answer, I think. And the last one is x and y. So x is 3. No. Yes, x is 3. It's the last time. X is 3. And y is 2 times 3 is 6. 6 plus 7 is 13. All right. Is that it for the challenge? One more, two more challenge. Okay. A cashier distributes change using the maximum number of $5 bills, followed by $1 bills. For example, 19 yields 3 5s and 4 1s. Write a single statement that assigns the number of $1 bills to variable num1s given amount of change. Hint, use the percent operator. So I would say that there is num1s is where I want the answer. Num1s equals amount to change modulo 5. Is there a 5 or do I just put 5? I guess I just put a 5. What's the next one? Total budget and product cost are read in. Product costs, a product costs this so much to me. This, and the budget is given by that. Assign remaining budget to the remaining budget after making as many products as possible. All right, I got to know the remaining budget, the remainder budget. Remainder budget. I don't. It's not asking me how many products. It doesn't ask me to output how many products, just how much is left over. So I would say that remaining budget is equal to total budget modulo product cost. As we have them be integers, so we can do this modulo thing. All right, so let's, is that right? Gee. Guess that must be right. All right, what's next? Declare double variables. Oh, get it. All right, so I got to declare a bunch of double variables. Can I do multiple, declare multiple? I think I can. Java. Multiple variable declaration. Declare multiple variables. We can declare and assign multiple variables on one single line. Okay, well, I'm just gonna, how do we do this? Ooh, can even do that. All right, well, I'm going to do it that way. So I'm going to declare, put my additional declarations here. Okay, so I'm going to say double x1. Oh, because that way I can copy and paste. See. Get that. Okay, so I just declared all these variables. I separate them by comma, right? Now, yeah, comma. Okay. All right, so that's declaring all four damn dudes. And then read each variable from input in that order. Forcing me to x1 equals scanner next double. And I got to do 4 of these, I guess. Oh, I guess that they want me to put it down here. Okay. 2, 3, 4. Oh, I see. So I'm gonna, can I copy it? No. Okay. So then I gotta compute average number, AVG number equals oh, I'm gonna do parentheses x1 plus x2 plus x3 plus x4 close divided by 4. And all those x's are floating points, so are doubles, so I can just do that. Oops, not z. Where did I? Z. Okay. And looks good. So what's next? This is the number of seconds, and I'm supposed to get that. Okay, so first of all, I'll read in the total seconds, and I want to compute the number of hours is okay. First of all, let me compute the number of minutes. So I'm going to say num second, number of total seconds. Okay, let me just go num minutes equals num seconds divided by 60. Okay, and the number of seconds left over is no, this is total seconds. Total seconds divided by 60. That's the total number of minutes. I'm not done with that yet, but the num seconds equals, I guess it's just total seconds. Oh no, it's 60. All right, and then we have number of hours equals number of minutes mod 60, no, divided by 60. And the number of minutes now equals, this is right, 60 mod minus, like, I'm guessing, I'm gonna guess mod. Okay, I'm now in guess mode, but I need num hours, num minutes, num seconds. Yeah, that's gonna be a small number. Num hours is gonna be that. Okay, I'm gonna see if this is right. I don't think it's gonna be right. No, it's not right. Okay. Yeah, okay. So first I compute the number of, okay, so I'm gonna do it a different way. The number of minutes equals the total number of seconds mod 60. Oh, yeah, divided by 60. Number of seconds is number of minutes. Oh, I change. I'm going to change this to number of hours times. I'm going to change this to is that right? Ah, that's right. Whew. Don't ask me how I got that one. All right, so that's end of 211. And oh, I'm going into that. So these are 211. Okay, so I would go through type conversions. That's pretty important, actually. I wonder why I left that one out. You should go through this too, darn it. Should have made this. Is there a challenge for this one? Okay, typecasting. Okay, that's how you do typecasting. Shoots, I should have included this as a section. I think I will. It's gonna affect, it'll affect the textbook. I'm just gonna okay, so type conversions. Type conversion is a conversion from one data type to another, such as an int to a double. Compiler automatically performs several common conversions between int and double types, such as automatic conversions, and this is called implicit conversion. Okay, I've decided to add this section. So if we go back to the top, hit refresh, and now when you look at yours, you should see that it's no longer optional. Okay, real quick, I'll go through all of them right now. It's important because this is one of the unique things about a language, and that's how this type conversion can work. One of the main differences between languages is types, how types are handled. So anyway, when you have mixed types in an expression, there's this implicit conversion that goes on, and basically if you're mixing doubles with integers in the same expression, they're all gonna be treated like doubles. And so, that's pretty common. There's this thing called typecasting where you can put the new type, how you want it to be treated, you can put that in parentheses in front of the integer. So for example, here we've got, in this example, we've got these integers, 3 integers, but we want to compute an average kids per family. And so if we set these integers equal to these values, if we just do, you know, if we just add the 2 kids, sets of kids, and then divide by the number of families, we would end up with an integer. And so we don't want that. So we can do this casting where we're going to add these 2 numbers together, and then we're going to cast it as a double type. And then we've got these number of families down here, and we're going to cast that as a doubles type. So that means when we do the division, it's going to be a floating point division, in which case we'll get the decimal point. Okay, so that's the whole idea behind typecasting. And you want to make sure that you're typecasting the right thing. Like, for example, here, really you want to either, typecast this or typecast this as being a double. But in this particular example, we are going ahead with the entire calculation first, because it's in parentheses, before we apply the typecasting. And so that's not what we want, because this is going to compute to an integer, and then we're just typecasting an integer, and we lose the decimal point, the fraction, and that's what we don't want to do. Okay, so let's do these challenges here. Okay, the first one is so we got this number, and number times number, print line new number. Well, I guess it's just 1 times 3 is 3, and it's a print line. That's pretty easy. Here we have 2 times 1 is 2. I think I do 2.0. Yeah, okay, it does print the decimal point. Here we got some doubles and some doubles, and we're going to print 4.0, I believe. They're all doubles. And the last one is, we have a number, and then we integerize it, so it becomes 1. Yep, drops the fractional part. Okay, here we have, we got these integers, and we do this calculation, and then we print out something. So let's print out the first one. Kids in, okay, so we're going to add the 2. Okay, so we're finding the average. So 9 plus 6 is 15, divided by 2 is 7.5. But it's all integer, so it's just going to be 7. And the last one is we're going to double, well, we've doubled this. So, and we've doubled this. So it's 15.0 times 2.0, which is 7.5 with the decimal point. All right. So what's this one? Type conversions. Integer variable num units is read from input. Typecast num units to a double. So we read this thing in, oh, okay. Do I just do double stat? Double num units. Yeah, right. right? Given that, complete the calculation to convert integers to the double variable days. So the double variable. So I want to go double variable. Well, I guess I'll just do this double. It's not letting me. Let's see. While I hit refresh, and let's try again. Like, so I got this one. How do I go here? Oh, check. Oh, I didn't type anything. Okay, let's do this again. Okay, I'm going to get this one wrong. And I'm supposed to. So let me. So what do I do? It's not. If this thing is not working, is it? Oh, now it's working. Okay, I delete this. Oh, good. Oh, all right. Something was my JavaScript was fine. Okay, so I got to compute double num days. I'm supposed to figure out the number of weeks. Oh, so this must be divided by. Yeah, okay. Let's see if this works. Oh, yeah, that makes sense. I wonder how I do that. Okay, so how about really? Is it supposed to be? Am I reading this wrong? I guess I'm reading this wrong. Maybe I'm supposed to. Let's see what this does. I guess I am. I guess I read it wrong. Okay, what's that? All right, what's next? I was going to do something different. Okay. Uh, we've got the couple. We've got these integers here. Compute the average weight of pairs per person each person receives. Average weight is that okay? So if so 350 divided by 10. So you don't want to add the two together. We want to go num average weight is equal to, let's see if this works, double pair weight 1 plus pair weight 2 divided by people. Okay, now I'm thinking that it's going to do this first, which makes it a double, and then it's going to divide by the number of people, and since one of them is a double, it's going to result is going to be a double. I do not believe it's going to do this first, in which case it would be integers, you know. So let's see if this works. Let's see if this, I had that question earlier and I was going to try to test it. Oh, I guess, okay, so it does do it. Okay, so it does do it first. All right, so we have done all the challenge activities for chapter 2 that are required, including the, these will fill up, including the added section on type conversions. The last thing we got to do is this thing. This is just really simple and stupid, and I just had to throw this thing in someplace. And it's only just, you know, if you realize that if the assignment here displays this, really what's going on is your program prints this out, and then the user enters the 5. That's the return. And then your program prints this out again. So if you see in the assignment, it's supposed to look like this, don't also print out the 5, because that's the user typing in the 5 followed by the enters key. So that's all this is saying. So what are we supposed to do with it? Try submitting it for grading. Notice the test cases fail. Okay, so see, so what am I supposed to enter it? Okay, so so I'm gonna put a you know, 35 or whatever, and I'm gonna run the program. And the output is this. But really, I'm not supposed to print this 35 out. So if I click submit and try this, I don't get all the points because when it was tested with entering 3, you know, this turned out correct, but this was there, and it wasn't supposed to be there. That's why it's yellow. And why was it there? Because the user mistakenly echoed the number. So you just gotta, you know, comment this out and do it that way. Now submit. And you get the points. All right, so I've completed the second chapter, and make the next chapter pretty soon. Thanks for watching.